Hello, Algebra 2 students. This is a riveting lecture on factoring of the form ax squared plus bx plus c. We are still factoring. The difference between factoring in section 4.4 and factoring in section 4.3 is going to be basically everything. And the reason why we can't use the strategy that we used in section 4.3, if you remember 4.3 said factoring of the form x squared plus bx plus c. If we are factoring it where there is no number in front of the x squared, it's pretty simple for us to do. But if we are factoring when there is a number in front of x squared, we have to think about this in a completely different method, a different process. So 4.4 would be when it's ax squared plus bx plus c. If the number in front of x squared is 1, we can use the method from section 4.3. If there's a number in here that isn't 1, we have to use section 4.4 strategies, and the way that I teach this is called the box method. So let's review really quickly what was section 4.3. Remember, the whole point of really chapter 4 is we're trying to solve quadratics like this. And one of the first methods that we learned, actually the first method that we learned was factoring just with traditional factoring when the x squared term doesn't have a 1 in front. And what you do is you go to the c term and you list the factors of c. Okay, what multiplies to negative 12? Well, you could have 1 and 12, 2 and 6, or 3 and 4, and one of them is going to need to be positive, and one of them is going to need to be negative because it multiplies to negative 12. What you do from here is you say, okay, which of these pairs, 1 and 12, 2 and 6, or 3 and 4, would add to positive 4? 1 and 12, no matter how you add or subtract them, would never add to positive 4. 2 and 6 could add to positive 4, right? If our 2 was negative and our 6 was positive, now these two numbers add to positive 4, and when you multiply these two numbers together, they multiply to the c term, right? They multiply to the c term and add to the b term. That's how you choose your correct factors. And how you'd write that then would be x minus 2 and x plus 6 equals 0. If I had just told you to factor the statement, this is the statement factored. That doesn't look like what I would have asked on this question, though. This looks like a solve equation, and it's a solve equation because it's got an equal sign there. Then what I'm asking you to do is tell me what values of x make this a true statement. All you do from there is you say, okay, remember, we have this thing called the zero product property. It says if you have something and you multiply it by something else, and their product is 0, they multiply to 0, then either A must have been 0 in the first place, or B must have been 0 in the first place. So that's what we have here. We have something times something else, and it equals 0. So then this must be 0, or this must be 0. What would make this one 0? The number 2, right? And what would make this one 0? That would be the number negative 6. So my solutions here would be 2 and negative 6. This is a really nice method because it's short and it doesn't take you very long. However, when there's a number in front of x squared, this no longer works, and we're going to have to use something that is both more challenging and more time consuming. And the way that I teach it is called the box method, but the textbook does use this table method. And I'm not going to tell you not to use this. If this makes sense to you, I do want you to do that. I'm not going to go through this example, but if you want to try the books method, go ahead and do so. Like I said, I'm going to teach something called the box method. I'm going to say it isn't significantly shorter, or I think it's better, but it's not like, it still isn't simple or easy or quick. It's still going to be complicated. Here's our steps for using the box method. Step 1 is to create the box that looks like this. I'm going to refer to this box as box number 1, 2, 3, and 4. When you make this box method, it's always going to have the variable. It's traditionally x squared in the first box. The second and third boxes will have just the plain old, whatever the variable is, most likely x. And the fourth box will have no variable. So that's the box that you create. Step 2 says to multiply the a and the c. Remember, the thing in front of the x squared is the a, the thing in front of the x is the b, and the thing without an x is c. So you're going to multiply the a and c, and I always write it right here. Apparently I can't count, but step 3, number 1, says list the factors of that number. Just like over here we listed the factors of the last term, negative 12. Here it's not going to be the last term, the c term. It's going to be whatever a times c is, the number that we wrote out here. And you're going to list the factors of that number. You are going to be still looking for which factor pair would add or subtract to the middle term, the b term. That's not unique to this. We just did this in the last section. I do want to say if none of these factor pairs would ever add to the middle term, it's not factorable. That doesn't mean we couldn't solve it. This whole chapter is on solving quadratics, and we're going to learn a bunch of different ways. It just means that we can't solve it using this method. We can't solve it using factoring. Really, what you would use is the quadratic formula, and I know you don't know the quadratic formula yet, or you probably don't remember it. However, when you're taking a later test, I just want to remind you, if you ever do try this and it doesn't work, try the quadratic formula. That'll always work. Okay, so then place the a term in the first box and the c term in the last box. So whatever number is in front of x squared goes here, and whatever number doesn't have a variable will go here. And those two factor pairs that you had, right, that added to the middle term, they're going to go in boxes 2 and 3. Step 5 says to identify the greatest common factor of the top two boxes. Remember, greatest common factor, factors are what multiplies to those numbers. So if you listed what multiplies to this number, and you listed all the factor pairs, all the things that multiply to this number, the biggest number that they have in common is going to go right here. And then you complete the rest like a reverse multiplication table. I'm going to show you what that looks like, but remember what a multiplication table is. It was like a full table of 1, 2, 3, and then 1, 2, 3, it would go on. And it would be like 1 times 3, and that would be 3. 2 times 2 is 4, right? That's a multiplication table. You're kind of doing that. Whatever goes here times whatever goes here should be this one, right? Because you just follow the table across. Whatever goes here times whatever goes here would equal this one, this box. So that's what I'm saying when I refer to it as a reverse multiplication table. It's kind of confusing, but I think you'll understand it once we actually see it. We do have quite a few examples of this. I do want to flood you with examples, and each one is slightly different. Sans, I guess, the second one. The first two are just traditional problems that then I kind of start mixing it up. So step 1 says to create the box that looks like this. And then we take the a term and the c term, and we multiply those together and write it outside the box. Then we list the factors of this number. There isn't very many. This isn't a very big number. There's only 1 and 6 and 2 and 3. So your next task is to find which factor pair could add or subtract to negative 7. Well, 2 and 3 could never add or subtract to negative 7, and 1 and 6 could. So this one isn't very tricky. Hopefully you see that if the 1 is negative and the 6 is negative, they would add to negative 7. Also, they multiply to positive 6. So that is going to be the correct terms. They are going to go in boxes 2 and 3, and it doesn't matter what order you put them in. I could put the negative 1 here, or I could put the negative 1 right here. And as long as the other one went in the other box. The a and the c terms, they do go into this box here and this box here. So that's probably the easiest part to follow along with the steps, but then steps 5 and 6 kind of get a little bit weird. Your next step is to identify the greatest common factor of the top two boxes. So I'm never going to do this every time, but I'll show you guys the first time. The factors of 2 are just 1 and 2. And the factors of 6 would be 1, 2, 3, and 6. So what's the greatest common factor? Well, it's 2 and 2, right? That's the greatest one they have in common. So 2 is going to go here. And also, this one has xx, and this one just has 1x. So in common, I could take out a single x, because this one has 2 and this one has 1. So what's the most they have in common is just 1. Next step is to think of this like a multiplication table, except I have the middle of the multiplication table figured out, and I need to figure out what would go here and here and here. So what I'm asking myself is 2x times something that goes here is going to be 2x squared. So hopefully you guys are understanding this, that would be, well, it needs an extra x, right? Because now x times x is x squared. And 2 times what is 2? Well, that would just be 1, right? 2x times 1x is 2x squared. That's a true statement, because the 2 times 1 is 2, and x times x is x squared. You, of course, wouldn't need the 1 there. You could have just written x. Either one would be correct. Now you just move on to the next part. Whatever goes here should multiply by 2x to get negative 6x. And hopefully you guys come up with negative 3, because the 2 and the negative 3 would make negative 6. And this one has an x, and this one doesn't, so x times, no x would just be x. Whatever goes here times 1x should be negative 1x. That would just be negative 1. And I really want you to get in the habit of this as a check. This one times this one should be 3, and it is, right? Negative 1 times negative 3 is 3. So if my task said to factor it like it did, this is going to be one set of parentheses, 1x minus 3, or just x minus 3. And the other set of parentheses is going to be 2x minus 1. I know that's a lot of work. It seems like it's a long process. It is a long process, but it will get faster. Let's try another one. Feel free to pause it here. This is not any different. You can try this one on your own. Your first step is to create the box, and then you multiply 3 and negative 5, and you get negative 15. Listing the factors of negative 15, you would have 1 and 15, or 3 and 5. Those are it, right? And which of these could add to the middle term? The 1 and the 15 could if the 15 was positive and the 1 was negative, right? These two numbers add to 14 and multiply to negative 15. So that means that it is the correct two terms, and they go in this box, and it doesn't matter what order you put them in. Place A is 3 in the first box, and C is negative 5 in the last box. And then we go about trying to fill in the outside numbers. Remember, your first step is to look at box 1 and 2 and say what's common between them. 3 has factors of 1 and 3, and this one has these factors here, 1, 3, 5, and 15. So the greatest common factor would be 3. This one has 2 x's, and this one has 1 x, so in common, they have 1 x. And now we complete the rest like a reverse multiplication table. 3x times something is 3x squared. That would just be x or 1x. Either one would be fine. 3x times something is 15x. Hopefully you come up with 5. 5 times 3 is 15. And x times, 1 essentially, or there isn't another x here, so it's just the 1. X times what is negative 1x? That would be negative 1. And as a check, is 5 times negative 1 negative 5? It certainly is. And so my factors are going to be x plus 5 and 3x minus 1. One thing I want to remind you is that this would be a really simple statement to FOIL, and make sure that you get back to the beginning, 3x squared plus 14x minus 5. If you weren't sure you got the right answer, x times 3x is 3x squared, and x times negative 1 is negative 1x. 5 times 3x would be 15x, and 5 times negative 1 would be subtract 5. Now your middle two terms could be combined, 3x squared plus 14x minus 5, and that is where we started. So you always should be able to FOIL that out and get back to factoring. Remember, going from this statement to this statement is called factoring, and going from this statement to this statement is called FOILing. and you should always be able to interchange them. Okay, this one is only different because it's set equal to 0. So the steps are going to be really the same. You're just going to have one extra step at the end. So this would be a great time to go ahead and try it, see how you do. Multiply the 4 and the 5 to get 20, and then list the factors of 20, 1 and 20, 2 and 10, and then 4 and 5. Which of those factor pairs would get you to -9 by addition or subtraction? 1 and 20 never could, 2 and 10 never could, but if the -4 and -5, those do add to -9. And they do also multiply to +20, so I'm very confident that those answers are correct. And that's what goes in boxes 2 and 3. Remember, the thing that goes in box A is going to be the 4, and 5 is going to go in the last box. From here, we use the greatest common factor of the top two things. 4 and 4 is just going to be 4. This one has 2 x's, and that one has 1 x, so it would be 4x. 4x times what is 4x squared? Hopefully you come up with x or just 1x. Either one would be fine. And then 4x times what is -4x? That would be -1. And x times what is -5x? That would be -5. Get in the habit of making that check. Do these two things multiply to 5? Yes, they do. And so I have factored it correctly. And factored it would look like x minus 1 and 4x minus 5. I do want to emphasize that if you switch the order of these two, it wouldn't matter because multiplication can be done in any order. Okay, so remember, this one has an equals 0 at the end, so it still has the equals 0 here. And our goal is to find out what value of x would make this a true statement. What value of x would you plug in for here, and you get 0 out. I already referred to this at the beginning of the lecture, but this is going to use the zero product property. If you have something and you multiply it by something else and you get 0, either A must have been 0 or B must have been 0. So what makes A 0? Well, the short answer is 1, right? 1 minus 1, that would be 0. And then 0 times literally anything. And it would be -1 in this case when you plug in the 1, right? But 0 times this would be 0. It does actually work when you plug in 1. To find out what makes this one 0, it is a little bit more complicated of a question. I want to know what would make it 0, so I'm just going to set it equal to 0. Then I would know what makes it 0 when I solve that. So for these more complicated ones that aren't just like x plus a number or x minus a number, just set them equal to 0 and solve it. Add 5, divide by 4, x equals 5/4. And so those are my two answers, 1 or 5/4. Either one of those, if I plug those in for x here, they would give me 0 out. So this is what it looks like if it's solving, and it'll be set equal to 0. Like I said, every one of the examples from here on out, I'm trying to show you something a little bit different. Hopefully you look at this and you recognize what's different about this one. This is going to be an example when the A term is negative. We actually never want the A term to be negative when we're factoring. And so what we do to avoid this is we actually factor out a -1. I know that might seem weird to you guys, but if we factor out a -1 and we take it outside of the parentheses, all that's really going to do is make everything else positive. This is like undoing the distributive property. So -1, if you were to distribute it back in, it would give you -4x squared. And this, essentially what it's doing is it's flipping the sign of everything. And this could be really easily checked, right? If we were to distribute the -1 back in, it should get us back to where we started. What we like about this is that now we're going to kind of disregard this -1 and just work with what's in the parentheses and work on factoring that. Now my a term is positive. Remember, the a term goes in the first box and the c term goes in the last box. So, I kind of skipped to 3. Now I'm going to go back up to 2. 4 times negative 7 is negative 28. And then you list the factors of 28. 1 and 28, 2 and 14, and 4 and 7. Now, which of these pairs would add to negative 12? 1 and 28 never could, and neither could 4 and 7. 4 and 7 could add to 3, or negative 3, or 11, or negative 11, but not negative 12. 2 and 14 could, if the 14 was negative and the 2 was positive, they do add to negative 14, and when you multiply those two things, you do get negative 28. So those are the two numbers that go in the second and third boxes. Once again, it doesn't matter what order you put them in these boxes. Now we do the greatest common factor bit. If you take out the greatest common factor of 4x squared and 2x, you would get 2x. And then 2x times what is 4x squared? Hopefully you're streaming 2x. 2x times whatever goes here is going to be 2x. That would just be 1. And 2x times whatever goes here would be negative 14x. That would be negative 7. Is 1 times negative 7 negative 7? Yes, it is. So when you factor this, this is what you get. We still have that negative 1 out front. And now it's set equal to 0. This in parentheses is one of the factors, and 2x minus 7 in parentheses is the other factor. Now, because this is set equal to 0, what we're trying to do is we're trying to find out what value of x makes it all work, right? What value of x makes this 0? This is still going to use the zero product property. Now we have essentially 3 terms. We have this number times this number times this number, and they equal 0. So it's like a times b times c is equal to 0. What that tells you is either the a must be 0, or the b must be 0, or the c must be 0, right? Doesn't matter what a and b are, because if c is 0, it's still going to multiply to 0. So what you would do is you would say, okay, what makes this one 0? Well, there isn't an x here. This is always just going to be negative 1. So it's impossible to make the a term 0. Here would be the b. We can find out what makes that one 0 because it does have an x. Remember, you would have to just set it equal to 0 and solve it. And you're going to do the same thing with this one. Set 2x minus 7 equal to 0 and solve it. Here you would add 1 and then divide by 2. So x is equal to 1/2. And here you'd add 7. So you'd have 2x equals 7. And then divide by 2. So x is equal to 7/2. So those are your solutions. You could definitely plug 1/2 in. Make sure when you substitute something in, like a half, you put it in parentheses, and you should get 0 out. You should be able to do the same thing with 7/2. Let's do this example as well. This is an example where, if you look, what makes this one unique is that there is no b term. We still have 9 as our a term because that's the thing in front of x squared. And we have negative 4 as our c term because that doesn't have an x. But we don't have a b term. And so all that's really going to mean is that the a term is going to be 9, and the b term is going to be 0, and the c term is going to be negative 4. Okay, it doesn't actually behave all that differently in this example, but I did want to specify the difference. This is when the b term is 0. So you still multiply the a and the c, the 9 and the negative 4, and you get negative 36, and then you list the factors of negative 36. The factors of negative 36 would be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. We're looking for which of these factor pairs could add to 0. And if they add to 0, they have to be the same number, essentially, right? Positive 6 and negative 6 is the factor pair here that adds to 0, the middle term, and multiplies to negative 36. So that's the thing that goes here and here. Remember, the 9 goes in front of the x squared, and the negative 4 goes in the So then we do the same thing. The greatest common factor of 9x squared and 6x would be 3x. And 3x times what is 9x squared? That would also be 3x. Carrying on, this one times whatever goes here needs to be 6x, and that would be 2. And 3x times whatever goes here needs to be negative 6x, and that would be negative 2. So this in parentheses, and this one in parentheses. Remember, this was set equal to 0. So then you just have to set each of these parentheses equal to 0, and that's going to be your answers. 3x is equal to negative 2, so x is equal to negative 2/3. Carrying on with this example over here, add 2. 3x is equal to 2, so x is equal to 2/3. These are both going to be your answers. Once again, you could easily check them by just plugging them in for x and making sure that you do get 0 out. That is all I have for you guys today for factoring of the form ax squared plus bx plus c. Just as a reminder, when there is no coefficient here, if it's just x squared plus bx plus c, we don't have to utilize this strategy. This is only for the examples where there is a number in front of x squared, something like 9, or negative 4 or 4. That's when we're having to use the box method. Okay. If there isn't a number in front of the x squared, remember, we could use just looking at the c term and listing the factors and writing it out. Please let me know if you guys have any questions, and good luck.